Um, and so these are some relative speedups with optics and CUDA. And so you can see that some scenes have like a small speed up, like the BMW, but we're getting some pretty significant speed ups on more complex scenes, particularly interior scenes, scenes with lots of shaders, scenes where the GPU sort of struggles to keep things coherent, which is important for GPU performance. And so yeah, on this particular GPU, we get like up to 7 times faster rendering on the barbershop scene than somewhere somewhat slow, somewhat less on other scenes. More and so it depends on the scene, but it's like up to 7 times faster with this with this GPU.
So the more complex the more complex the scene, the better the
Generally speaking, yes. Particularly, interior scenes with lots of light bounces, with lots of shaders, it tends to work. But like, if you have a simple scene, it's not going to help as much. But if you have like some super scattering here and all this stuff, it usually helps.
It's gonna be better. And one thing about this graphic that we're seeing now is that on one side is from 0 on CUDA is from 0 to 100, and optics 0 to 50. So actually, these lines would be half the size if they were.
Yeah, I mean, so CUDA is already faster than optics is already faster than CUDA, right? If you use it right now, and so this is so both optics and CUDA are faster than what we have currently in 2.93 basically. And so this is another, like, these are the numbers from one GPU from Turing generation. These from Ampere generation. Like, there's the speedups are a little less on the Ampere generation GPUs. Don't know quite why yet, but yeah, we're looking into that thing. But also here you get up to like a 4 or 5 times speed up on some seats. That's pretty significant, I think. Yeah, so I'll give it to. I'll just show now some videos from Viewport for Viewport rendering performance. I think Sergey can give a bit of background on what we're seeing. So this is, yeah, go ahead.
Yep, totally. So on the one side, you can see the cycles reporting the current master branch, which will end up in 293 release. On another side, you see the cycles X. So basically, what you can see here is that before the changes we're making, the navigation was way more choppy, and you could see way less of the meaningful pixels. You saw a lot of some of black pixels around the scene, which was not helping you to orient in space. So with some trickery for the algorithm of how we schedule things in Viewport and how we scale the pixels, we just managed to do way better perceptual viewport on the CPU. This is CPU with OpenImage denoiser, and before the changes we were making, it was very hard to navigate. It was almost unresponsive. It's a bit hard to show on a video, but I was moving my mouse hard during navigation, and sometimes it was just stalling for many seconds. With the Cycles X, it's always responsive.
That's crazy. OpenImage denoiser. I thought that's CPU, right?
That was CPU rendering, yes.
Wow.
With OpenImage denoiser.
Wow. Could you?
This is.
Sorry. Could you? A moment. I'm gonna lower the music on request. Because I look in the background, but I think it's just what you're saying is just so cool. What you're doing is just so cool. So, here. Sorry. Continue.
Okay.
That's the restart.
We were not very happy with is that it was feeling a bit epileptic with all those pixels, big and small pixels popping almost at the same time and whatnot, and that just didn't feel smooth enough. So we also addressed that. So just kind of to show how the navigation with GPU looks before and after the changes. And I think we also have the GPU Oh yeah. Other thing is while we were refactoring a lot of code, we noticed that adaptive sampling didn't work in viewport at all. So that's also being addressed, and as you can see from the picture, it converges to the it converges way faster and converges to the specific noise floor which you asked it to converge to. And other thing to note is in the topic of removing settings, the start resolution setting is removed. So the system will automatically choose the resolution based on performance of your compute device. Take in account how long does it take to render, how long does it take to denoise and things like that.
Wow, viewport adaptive sampling.
Yep.
Wow.
So, okay. Yeah, so now I'll just briefly mention like what's the next stage of the project. So first thing we'll do is we'll publish the code, we'll make it public, we'll invite, other people to contribute, existing Cycles contributor that we've already, discussed this with. And so of course, users will also be able to test it, but I have to warn, you that it's a prototype. There's lots of things missing. Things will render might render differently and so on. So it's not it's very far from production ready, let's say, and have to be sort of careful when testing it. But so the plan for us is one thing we'll continue doing is work more on tons of features. And before, when something's missing, it's usually because we think we can do it better. Like for the shadow catcher, we can take into account indirect light, things like this to have more accurate compositing with the shadow catcher. Another thing that we're planning to work on in the next.
Awesome. It's much more than what I was thought to sum up.
Be roughly. It's not example I was giving with like a few. Sometimes in CPU rendering, you have a few tiles. That's. So we think if we add back volume support and discard, we can do it in a way that's project supports all this.
We are fully living in a cycle, so we don't really cross the render boundary that much. There was something to integrate it differently with the draw manager, make it more friendly for the multi-threading, so that the cycles fully lives in its own thread without bottlenecking the up so far. Well,
to be given
tiles,
so they fit in the same
boss. It's definitely that's for fast to be on safe.
I think of course usability is important. So
definitely. There is a blog post just for people that want to read more. There is. Now we shuffle, guys. There is a blog post, right? That's gonna go out soon, with more explanation about how to get it eventually. The graphics that we've seen and more of the write-up. But yeah, looking at this,
yes,
that's insane. So the BMW takes as long as a full production shot from the Asian 327.
Well, I mean, that's not what I would read from the graph. Like we basically made the render times, all kind of similar, so they fit in the same graph. It doesn't necessarily mean that the noise level is similar.
The noise level. Okay. The noise.
No, it's just we just sort of fit them, tweak the number of samples so they all fit nicely in the single graph. So it doesn't. Yeah.
This is awesome. So, is there anything else you want to add? This is really.
Not really. I mean, I would like to thank like everyone who's contributed to Cycles in the past 10 years. Both developers and users and everyone who's made beautiful artwork with it. And just hope we can continue doing this for the next 10 years.
Oh,
that's a good word.
Yes. You, Sergey, you have to top that.
Oh, that's quite hard.
Yeah.
You can't top that, but yes, thanks everybody.
Well, thank you for working on this so hard, and just thinking that they're just suddenly opening cycles and rendering is just faster, just by not doing anything. But you have to do all the work. Yeah, once you do first, because you guys are working to tweaking. It's yeah,
Development. One step give us a few days. To deal with them.
take your time. There is plenty of other things going on around Blender to get excited about. But Cycles X, Cycles 10, how do you call it?
We call it Cycles X, but I mean, it's just a code name for the project. You know, once it folds back into Blender, it'll just still be Cycles, of course.
Just your cycle. Awesome. Well,
What about render animation?